binomial theorem. That's the free lunch program. Binomial. Okay. Anyway, so it involves combinations, and this means n items taken so many things at a time. And we're going to do this more in chapter 12 when we talk about committees and things like that. But this is a key that's on your calculator. But for instance, if you have something like 7 combination 3, which looks like this, right? This means 7 factorial. You guys know what factorials are, right? 7 times 6 times 5 times 4 times 3 times 2 times 1 over r factorial, which is 3 factorial, and n minus r factorial means 7 minus 3 factorial, which is 4 factorial. So 7 combination 3, and sometimes they call this 7 choose 3 because you're choosing 3 items from a set of 7 of them, where the order does not matter. But we'll talk more about that when we get to. Is it like what? Yeah, kind of like that. We'll do that in the next chapter. Yes, Nick.
Write that 4
7
comes.
minus 3. Okay, so from this formula. So this means, so if I were to write this all out, which you don't have to every time, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, right? Times 4 times 3 times 2 times 1. But what really happens, since this is all being multiplied, you can cancel out all of those things. You see that? Okay, so you can cancel out 4 times 3 times 2 times 1. So what this becomes is 7 times 6 times 5 over 3 times 2 times 1. Another way you can think about it, this number down here gives you the number of items on the top, the number of numbers that you're multiplying. So if it's 7 combination 3, it's going to be 7 times 6 times 5, and then you're going to divide by the factorial that's down there, right? 3 times 2 times 1. And when we get to combinations, that would be like the same as you have 7 people to choose from for a committee of 3 people. How many different committees could you make? Or if you're a baseball player, you have 15 different teammates. How many different 11-person teams could you make? But that's where the order doesn't match. So you can't, without regard to batting order or something like that. But we're going to worry more about that in the next chapter. I don't know what this line is, right? Okay. So so 3 combination 1 just means 3 factorial, right? Over 3 factorial over 1 factorial times 2 factorial. Yes? Okay? Which just means that, or it's just, the other way to think of it is that's just, so there's 1 item in the set, really, so it's 3 times 2 times 1 over 1 factorial is just 1, right? Over 2 times 1, so that's just 3, okay? So that's just 3. And by definition, down here, if you have n items in a set and you have a 1 down here, it's just equal to that number up here. Okay, so these are some rules to know. N combination 0 is equal to 1. N combination 1 is equal to n. N combination n minus 1 is also equal to n. And n combination n, is also equal to n. And n combination n is equal to 1. So this one here, 4 combination 2, that means you have 2 things. That's just the shortcut way is to write this as 4 times 3, because I know I have 2 items, and divide that by 2 factorial. Okay? So that would be what? What's that equal to? So that would just be what? 8. Okay, and you could show, so that would be 8 factorial over 7 factorial times 1 factorial, right? So this would be, or you could think of this also as 8 times 7 factorial over 7 factorial, right? And those are what? See, guys, it's because the formula says it's n factorial over r factorial times n minus r factorial. So 7 is r, right? And this is 8 minus 7. Gotcha. And then this one, I think to do that one, that would be 65 factorial over 15 factorial times what? 50 factorial? And that would be really hard to do. That would give you some huge number, okay? But you can do these on your calculator. You know how to do them on your calculator? There's, if you go over to math, let me show you, sorry. If you go over to math, but we're not done yet. Now we got to teach about the binomial, how that applies to binomial theorem. So in this thing, if you go math, hit math, and then you go over to PRB, which is over here. PRB. There you'll see NCR. Okay? So what you'd have to do for that particular one is you would have to go 65, then go to math, then you'd have to go over to PRB, and then you'd have to go, whoops, I hit the wrong thing. Math. Sorry. These things are hard to operate. 65, math, PRB, and then go down to NCR, which is 3. And then you plug in your 15, is that what we wanted? 60. And then if you hit enter, that's a really big number, 2.07 times 10 to the 14th power. Okay, so that probably wouldn't fit into your calculator if you tried to multiply all those numbers. Yes, sir?
Yeah, why would it do that? Because 15 times 50 factorial on the bottom, wouldn't the 50 cancel out at 65? So it would be 15, 18.
No, no, it'd be 65. You'd have 65 times 64 times 63 times 62 times 60, all those 60s all the way down until you get to 50 factorial. And then the 50 factorials would cancel out. And then you divide that by 15 factorial. So basically it'd be 65 down to 51 divided by 51 factorial. Okay? So all these factorials, what's nice about all these factorials, they are also found in Pascal's triangle. Where'd my thing go?
Pascal's triangle, where the number is the sum of the two numbers combined.
Matt? Why does that keep disappearing? I don't want that to go away. What? Hi. Let me see if I can. I don't know why that keeps disappearing. I just want to get it back. So in Pascal's triangle, okay, which is this thing right here, okay, this is row 0, row 1. You know how you generate Pascal's triangle? Have you seen that? 1, it goes 1, 1, 1, and yeah, and the top two numbers, so it's 1 all the way down here, 1 all the way down here. 1 plus 1 equals 2. 1 plus 2 equals 3. 3 plus 3 equals 6. So if you add any two numbers above it, it gives you the next number. So this is 4, this is 6, so 3 plus 3 is 6, and 4 plus 6 is 10. Well, if I, like this number right here, what's kind of cool about Pascal's triangle, let's say I want this number right here. This is row 5, right? Since this is row 0, you have to remember that this is row 0, row 1, and this is column 0, column 1, column 2. So this right here, this number 10 is row 5, right? Column what? 0, 1, 2. You see where that comes from? And if you did on your calculator 5 combination 2, you would get out 10. So all those numbers in Pascal's triangle are also combinations. So this one, like 35, that would be 7 combination 0, 1, 2, 3, 4. See that? 7, 0. This would be the 7th row, right? Row 7, 0 column, 1 column, 2 column, 3 column. Okay? So if you did 7 combination 3, you should get 35. Or 7 combination 4 for that matter. They'll be the same. Because that's 7 times 6 times 5 times 7 times 6 times 5 divided by what? Divided by, 3 times 2 times 1, right? Which is, this is 6, right? What's 7 times 5? 35. There you go. Right there. And that's row 7, column 3. Isn't that cool? That's cool. Nolan?
Yeah, that's cool.
I know. Okay, so why do we need to know all that junk? Because it comes up in this thing called the binomial theorem. Okay, so this is the binomial theorem, and this is used to expand binomials with higher degrees than 2 or 3. Okay, so if you want to do like x plus 2 to the 5th power or something like that, you can use the binomial theorem to expand it really quickly without having to multiply x plus 2 times itself 5 times, you see? And combinations come up in the binomial theorem. So let me show you. The letters look kind of scary, but n choose 0, or n combination 0, is just what? 1, right? So you always start with, this is represents the coefficient, okay? So this is going to be 1, and x to the n. So the first term is always the degree, is the first term of this expansion raised to the nth power, okay? And then what happens is the x goes down by 1 degree, and this term goes up by 1 degree, okay? So for example, let's look at the next one on this list, expand. Oh, there it is, x plus 2 to the 5th. So this is going to be, with the binomial theorem, this would look like 5 combination 0 times what? X to the 5th. So that's your first term of that binomial expansion. Okay? Then this goes up by 1, this goes down by 1, and it's times 2 to the 0. But what's 2 to the 0? 1, right? So then you go 5 combination 1, but times x to the 4th, 2 to the 1st, okay? And what always has to be true is these two numbers have to add up to the degree of the polynomial. So this plus this in this case always have to add up to 5, okay? And then this is 5 combination 2, okay? And this goes down by 1, and this goes up by 1 squared. Have you guys done this before? 5 combination 3, x to the 2, right? 2 to the 3rd, and then plus 5 combination 4, x 2 to the 4th, x times 2 to the 4th, plus combination 0 is just 1. So when I rewrite it without any of the simplifying, I get x to the 5th, because this is just 1. What's this? 5 combination 1. That's just 5. Okay? So it's 5 times 2, which would be 10. You see that? Because this, whoops, sorry. Because this is 5 combination 1 is 5 times 2 gives you 10, so you'd have 10x to the 4th. Okay? 5 combination 2 is 5 times 4 divided by 2 factorial, which is 10. So you'd have 10 times 2 squared, which is 40. So you'd have 40x to the third. Right? Next term, this one also comes out to be 10 when you did that. Okay? So it's 5 times 4 times 3 divided by 3 times 2 times 1. Comes out to be 40, but in this case times 2 to the third. What's 2 to the third? It comes out to be 10 times 8, which would be 80x squared. Okay? And 5 combination 4 is the same as 5 combination 1. So that's just 5 times 2 to the 4th is 16, right? So it's 5 times 16. Is that 80 as well? 80x plus, and then 5 combination 5 is 1 times 2 to the 5th, which is 32. And that's what it looks like. I'll expand it out. What did I do? Oh, that should be x to the 4th thing. Okay? Why isn't there an x after what? There is, but it would be x to the 0. Okay? And x to the 0 is 1. Right? And likewise, there's a 2 to the 0 up here, but that's 1 as well. See? So always, these things need to add up to the degree of the polynomial. Okay? So this one works the same way, except instead of this being a 2 to the 4th, it would be a 2y to the 4th, and so on. So it gets, and then you have to worry about the negative sign there. But I don't have time to do that one because I want to do like this one over here. So if I want to do this one, write the find the coefficient of y to the 8th in the expansion of 2y to the 10th. So this one would start like 2y raised to the what power? 10, right? And 10, don't freeze them, raised to the 10. And then you would have a 10 combination 0 here, right? Which would just be 1, right? And then you'd have times 3 to the 0, which is also equal. So this would be the first term. They want when y is to the 8th, right? So the next one would be something, and the next one you have 2y to the 8th, right? And this would be 3 would be to the what? To the 2, because these two things have to add up to this, and this have to add up to 10. And then in front of it, I would have a 10 combination. Since this is the third term in the sequence, this would be a 2, because this is like the first term, second term, this would be 2. Yes, sir? Yes, sorry. Nick is right. That should be like that. So then when I multiply all that out, I get 10 times 5 divided, 10 times 9 divided by 2 factorial, which ends up being 45, because that's what this is, okay? Times 2 to the 8th, okay? Times 3 to the 2nd, which is 9. And times y to the 8th, because and so this thing here, when I multiply that all together, that would give you the coefficient of y to the 8th in this expansion, okay, which is a pretty big number. It's like 104,000 and something. I did it. It's 104 comes out to be 103,680. So 103,680 y to the 8. Okay? And then find the sixth term. Could you do that? So that one, it would look like 9, since the 0th term, or the first term has a 0 down here. The sixth term would have a what down here? 5, right? And so that'd be 9 combination 5. X to the, since the first term has a 9, is that a 9 up there? Since the first term has a 9 up here, the sixth term would also have a, it would have a 6, 9 minus 6, it would have a 3. And the 2 term would have a 5, no, would have a 6. I'm sorry. The sixth term? No, that's not right. It is right. X to the 9th.
X to the 4th.
These two have to, would that be X to the, let me look at my notes. Hold on. No, that's wrong. It would be X to the 4th. That's right. This would be X to the 4th, 2 to the 5th. So this and this number are the same, okay? And this number you get from subtracting it from 9. Since this is the sixth term, this number is 1 less than 6. This number is the same as that number. And you subtract this minus this. So you would figure out what that is, multiply it by 2 to the 5th, and then X to the 4th would give you the sixth term of that sequence, which comes out to be 4,032 x to the 4th. So that's equal to 4,032 x to the 4th. The end. Sorry. Not that much homework on this, so you should be okay.